Okay, in 12.3, we're surface areas of prisms and cylinders. Okay, so a surface area, all right, is an area that goes all the way around whatever figure you're looking at. So the objectives are find lateral areas of prisms, find surface area of prisms, as well as cylinders. Okay. So characteristics of prisms. All right, we have the bases are congruent faces in parallel planes. So note, so the most important thing here, our bases are congruent faces. All right. Then we have the faces that are not bases are lateral faces. So that goes around the outsides. And then the lateral faces intersect at the lateral edges. Lateral edges are parallel segments. So if you look at that example, you should be able to see what the lateral face, the base, and the lateral edges. Okay, characteristics of prisms continued. A segment perpendicular to the bases with an endpoint on each plane is called an altitude of the prism. The height of the prism is the length of the altitude. So a prism with lateral edges that are also altitudes is called a right prism. And if the lateral edges are not perpendicular to the base, it is an oblique prism. Okay, so what that means is basically if the prism's standing straight up and the lateral edges are the same height as the altitude, then it's a right. Then that means it's right compared to oblique. All right. So L is the sum of the area of lateral faces, and the area of lateral faces equals A times H plus B times H plus C times H plus D times H plus E times H plus F times H. So imagine those were all folded up and the bases were laid back down. That's what would make the prism. Or H times A plus B plus C plus D plus E plus F, or lateral area equals P times H, okay? And that's kind of what we're going to use. So let's look at one here. Key concept number one. If a right prism has a lateral area of L square units, a height of H units, and each base has a perimeter of P units, then the lateral area equals the perimeter times the height. So let's look at this. All right. So find the lateral area of the figure to the right. So the height, okay, is obviously right here, right? From here to here is the height, because imagine this is a plane here, then that plane is going to run straight down to this plane. All right, so it's going to be the same height. So if our L equals the perimeter times the height, we have L equals P times 7. Okay. Now, what's our perimeter? Our perimeter is going to be what all these sides add up to be. So if this is 20, then that means this side's 20, this side's 20, this side's 20, and this side's 20, or 20 times 5, which is 100. So that's why we get our lateral area equals 100 times 7. All right, so the lateral area equals 700, and there you found the lateral area of a cylinder. So hopefully you see it's not that difficult. Okay? Let's look at another key concept here. If the surface area of a right prism is T square units, its height is H units, and each base has an area of B square units and a perimeter of P units, then the total surface area equals the lateral area plus 2 times the base. All right, now 2 times the base is 2 times the area of the base. And again, that's for the whole area. So let's find the surface area, the figure to the right. So the total surface area equals the lateral area, which we found is P times H, right? So if we do this, the L equals P times H, because that's just the sides. That's the lateral area. And then the total surface area is the lateral area plus the 2 bases, right? And that would be the total. So this is going to look like T equals P times H plus 2B. All right. Now I understand that this is a lot, and make sure you're writing these down. You'll have practice problems to do these with. So don't worry about it right now. Just try to keep following along here. So if we look at the perimeter times the height, then we would find the perimeter is 3 plus 4, okay, plus 5. All right, how did we know this was 5 up here? Because we know this is a right angle, so 3 squared plus 4 squared equals x squared. The Pythagorean theorem, you can find out that will equal 5. All right. So we have the perimeter, which is 3 plus 4 plus 5, okay, or 12. 12 times the height is 16, so that would be for the lateral area. And then we have plus 2, right, because 2 times the area of the base. The area of the base would be 1/2 of 4 times 3, right, because a triangle is 1/2 base times height. So 1/2 of 4 times 3, or 6. So we have 12 times 16 plus 6 times 2, okay, which would be 192 plus 12, or the total surface area is 204. All right, so hopefully you understand that. Those are just the two different ways we're going to go over this, okay? So, in this example, find the surface area of the figure to the right. Pause the video, see if you can do it. Alright, so the first thing you're going to do is the total surface area equals, again, L plus 2B, or PH plus 2B. So then we're going to find the perimeter. Alright, the perimeter is obviously 3 here, plus 9 here, plus 3 here, plus 9 here. Okay, so 3 plus 3 is 6, 9 plus 9 is 18, or 24. So we're going to have 24 for the perimeter, and the height is going to be then 12. Right here. Okay, so there's the perimeter times height. Now we're going to have 2 times the base, right? So the base, here's one base, we can just label base, and here's the other base, and they're going to be the same thing. So 9 times 3 would be the area of this rectangle. So 9 times 3 is 27, so 2 times 27 will give us 54, and then you put everything together, 288 plus 54 equals 342. All right, hopefully you understand this. If not, let me know in enrichment. So, here's our next section is going to be finding the lateral area and surface area of cylinders. Okay, so cylinders are pretty easy because they're normally the same. Now, the axis of the cylinder is the segment with the endpoints that are centers of the circular bases. If the axis is also the altitude, then the cylinder is called a right cylinder. Otherwise, the cylinder is an oblique cylinder. Okay, so that means if the altitude goes straight from one base to the other and forms 90 degrees, then that means the right cylinder. If it doesn't, see how this kind of comes this way and the height is really from down here, then that's an oblique cylinder. All right. So the net, which this is called a net when you fold. If I took a cylinder and I just folded everything out, that's what a net would look like. All right, it's composed of 2 congruent circles and a rectangular. All right, so the area of this rectangle is the lateral area, and the length of the rectangle is the same as the circumference of the base, which is 2 pi r squared. So the lateral area of a right cylinder is 2 times pi rh. Okay? So let's take a look at this. All right, so find the lateral area of a right circular cylinder whose base has a radius of 4 inches and whose height is 6 inches. So this got messed up a little bit, but the radius is 4 and the height is 6. Okay? So how do we do it? Well, we know using the formula lateral area equals, again, remember this 2 got covered here, but that's a 2 times pi rh. Okay? We get 2 times 3.14 times 6, because that's the height, times the radius of 4. Okay? Okay, so surface area. If a right cylinder has a surface area of t units squared and a height of h units squared, and the bases have radii of r units, then t equals 2 times pi rh plus 2 pi r squared. So basically it's the lateral area of the rectangle plus the area of the 2 bases. Get it? So, let's look at this one. Alright, the diameter of the base of a cylinder is 12 centimeters and the height is 8. Find the surface area of the solid cylinder. So remember, the total surface area equals 2 times pi times radius times height plus 2 times pi r squared. Okay? So, by putting that in, again, it's just simple, just by plugging numbers in. 2 times 3.14 times the radius, which is 6, times the height, which is 8. Plus 2 times 3.14 times the radius, which is 6, squared, or 36. So that comes out to equal 301.44 plus 226.08. So your answer should be 527.5. So the only thing that's difficult about this is making sure you know what the total area is and the surface area. So this equation for total area, sorry, I just got a little messed up. That equation for total area, and then the surface area equation as well.